Good day, Professor Dr. Teh Hua. We are Group World-Class Miner. Before we begin, allow me to introduce my team. Myself, Hon Ting, along with Ching Yan, Wei Hong, Yun On, and Yang Jian. Creating hotel booking cancellations is essential for the hospitality and the travel sectors. To address this, two hotel datasets with demand data have been collected. Our business objective includes understanding the target customer groups, identifying key factors influencing booking cancellation, and predicting the likelihood of a booking being cancelled.
Alright, there were two real-world datasets being used for our data mining project, a hotel reservation dataset and a user navigation traffic dataset. The first dataset includes an arrival date table, customer information table, hotel table, marketing table, and reservation table. The reservation table consists of all the booking details where the isCancel variable is selected as the target variable. The second dataset is about the user navigation traffic on our booking platform, which consists of session ID, date time, page visited, and customer ID. Now, I would like to talk about how deep feature synthesis was performed using feature tools in Python. For the first step, we need to identify what are the entities and entity sets. For this dataset, we have assigned 5 entities, which are reservation, hotel, arrival date, customer, and marketing entity. Then we assign relationship for each entity using respective unique keys such as hotel ID, arrival date ID, customer ID, and marketing ID. Lastly, we can perform deep feature synthesis by assigning it with the entity set. Here are some of the synthesized features selected for the model training later. The day, weekday, month, year components are extracted from the reservation status date attribute, which allow the model to capture daily, monthly, and yearly patterns. Average and maximum waiting days of customer offers insight into how long guests typically wait for their reservations. The common room and meal types allow the hotel to identify the most frequent room types and meal plans chosen. Average weekday and weekend night stays give an understanding of the typical length of stays on different days. And lastly, total reservations by date count the number of reservations for each arrival date to identify high demand periods. Therefore, we have improved our dataset with the newly synthesized features and described it with a star schema. In this star schema, we have one reservation fact table with all the attributes related to the reservations, and another 5-dimension tables with hotel, arrival date, reservation status date, customer, and marketing dimensions.
Next, in our project, the ETL process is done by using a tailored OpenStudio for data integration. First, in the extract part, 5 T file input delimiter components are used to extract data from CSV file. It is done by specifying a schema, which involves setting up a primary key, types, and other. Next, in transform, 3 processes have been done. First, the data type for agent and company are converted from string to integer with T common type components. After that, a new dimension table, which consists of synthesized year, month, weekday, and day of reservation, are separated from fact table using T-mat and T-unique row components to form new table called reservation status dates dimension. Later, all tables are joined based on the foreign key in the reservation fact table. And finally, for the load part, the consolidated table from T-mat is saved to a new CSV file. The next stage is data preparation. For this part, 2 tools has been used, which are SAS Enterprise Miner and Tailored Data Preparation. The first step is to import a file to SAS EM, which is done by using a file import nodes, and then set the rows and level for each file and variables. Next one is data profiling for checking the data quality. In SAS EM, Stack April node can obtain an overview of the data, and from there, we can know that columns like country and year have missing values, and numerical variables are skewed to the right. In the tailored data prep, the same process can be done, but is limited to 30 Ks of records. And then for the imputation part, mode imputation and median imputation are performed for categorical and numerical variables respectively. In SAS EM, it is done by using an impute node, whereas in the tailored data prep, it is done by using a built-in function. Moving on to the SEMA methodology, which our group has implemented it when performing data mining in SAS Enterprise Miner and K9. So here's the high-level view for our SAS EM framework. The first step is sample, which our group employed systematic sampling to obtain 50% of data set with the sample node, resulting in around 60K of record.
Okay, now I'll explain the explore aspect of the SEMA methodology. First, we use the stat explore node for EDA to explore data distribution and relationships. For example, in multivariate analysis, we can conclude that in July, the ADR of room reservations is higher between 20 to 30 July. Then we perform feature selection in classifying reservation cancellations with decision tree using entropy and Gini methods. We have selected several significant features like deposit type and market segment. In association rule mining, we can discover patterns in user behavior to optimize platform design and enhance user experience. The association rule with the highest lift of 3.99 suggests that personalized content may lead to higher conversion rates, whereas in sequence analysis, we can study the sequence of pages to help enhance user journey and increase reservations. In this case, we identify some common paths helpful for streamlining website navigation, such as homepage to search results page. Using time series clustering, we can group similar temporal patterns to reveal common trends or behaviors, and then tailor targeted strategies to minimize cancellations. We obtain two clusters based on market segment and distribution channels with the hierarchical structure in the dendrogram. We also set the largest group of time series 23 as the target and observe that time series 10 has the highest similarity, indicating that both of these market segments may share common traits in decision-making processes. Next, with clustering analysis, we have found K-means clustering in SaaS Enterprise Miner. From our results, segment 18 has the highest percentage of 37%. The customers in the segment have characteristics like predominantly booked through online travel agency at moderate level and high preference for bed and breakfast meals. Lastly, we utilize the advanced DB scan in 9 for segmentation using these variables and identify 3 clusters. The clusters are mainly separated by total of special requests, with both lead time and stays during weekdays and weekends increased from cluster 0, 1, and 2. There you go. These are the insights and recommendations for each cluster. For instance, customers in cluster 0 have short stays and moderate spending, which suggests for marketing short-term promotional deals and emphasizing efficiency in booking and service delivery.
For the modified part, a drop node is used to drop non-selected items based on the results from variable selection using decision tree. The target and the top 10 variables with the highest importance scores are selected out of 47 variables. Next, we use the data partition node to split the dataset into training and validation sets in a 7:3 ratio using the stratified method. The last modification is one-hot encoding and standardization. We use the transform variable node to transform nominal and interval data. The below figures is how we set the method of transformation for each variables. Moving on to models, we have chosen 5 types of model to predict hotel booking cancellations. The first model is decision tree, which is a tree-like model of decisions that splits data using features and decision rules, and then it makes predictions at the leaf nodes. Here, we employ 4 settings to investigate different levels of fitting on each decision tree, namely underfitting, normal fit, overfitting, and raw of overfitting. Here, the normal fit tree performed the best for the validation set compared to others as seen in the bottom figure, while the underfitting tree has the highest misclassification rate and also the lowest score across all matrix, which means the underfitted tree did not learn the pattern of data well due to the limited structure. For the overfitted tree, it shows greater score in training set but lower in validation set. The diagram here shows the tree started by splitting using deposit type, following by agent, country, previous cancellation, lead, and other features in deeper branches. The second model is random forest, which is an ensemble learning algorithm that uses a collection of decision trees to make predictions. Setting 1 here is the best configuration, which consists of 150 trees, maximum depth of 30, and 0.5 observation in each sample. It managed to achieve the best accuracy for both train and validation set as shown in the figures. For the third model, which is a support vector machine, which classifies data points by defining the hyperplane that maximally separates different classes in high-dimensional space. The model with interior point optimization method achieved higher accuracy, lower error rate, and higher sensitivity. As for the fourth model, gradient boosting, which combines weak learners like decision tree into a single strong learner in stages. The best configuration is with maximum branch of 5, maximum depth of 5 to achieve the best accuracy of 84.7%. The last model is neural network, which emulates human neural processes for signal processing. The best configuration of softmax activation function, entropy error function, and 20 hidden units have achieved a noteworthy validation accuracy of 82.5%.
In assessment, various metrics like misclassification rates, precision, recall, F1 score, and accuracy are employed. Our modeling involves 5 distinct approaches, with gradient boosting showcasing exceptional performance in misclassification rate, recall, F1 score, and accuracy during validation. Noteworthy that random forest emerged with the highest precision score of 0.849. Our future plans involve extending the dataset timeframe, including more hotels, and incorporating data from more countries to provide a global perspective. The next phase includes deploying the models for the real-world scenarios. Throughout our projects, we utilize a diverse toolkits including feature tools, Talent Open Studio, Talent Data Prep, SaaS Enterprise Miner, and Knife. The application of the Sigma methodology guides us for the analysis, including association rules, sequence analysis, time series clustering, traditional clustering, and DB scans. That's all from us. Thank you very much.